Hello everyone, welcome to the solutions for the sixth term entrance problems, and we are looking into the past year questions. Okay, we had already done quite a few of the past year questions, so let us continue it. Alright, and as usual, I am not doing them in any particular order. I am trying to select the problems that would give you a much more fundamental idea of what is to be expected in the exams, as well as selecting questions from various walks of mathematics. Alright, so this question I've selected from number theory. Well, it's not technically number theory because you are not using any of the rules or theorems that are very prevalent in number theory, but this is more of general mathematics, right? If you have a sense of what calculations are to be done regarding square numbers or how square numbers behave, you can probably attempt this sum without any formal knowledge of number theory. All right, so bear with me as the question appears to be a bit smaller in font size. That's because it was a lengthy question and I had to shrink it down so that the camera does not interfere with it. Alright, now I'll read that question out. That will make it much more easier for you all to follow it. So it says find an integer n such that n square less than 33127 less than n plus 1 whole square is satisfied. Alright, this is what we have to calculate. Now, this is basically just guesswork, right? And a lot of calculations. So how will you deal with this? The easiest way to deal with this is to have a calculated guess of where the square of n might lie. Okay, see, that is the number in the center of n and n plus 1 square is 33,127. Right now, if I were to take 180 square, that would give me 32,400, right? Because it's 32400. Why do I know this? Because we are always instructed to at least remember the squares from 1 to 20. Alright, they are very useful. Even if you do not remember them, you can calculate them quite easily, but why spend that time in the exam, right? In the exam you will always almost be short of time, so anything that you can do to improve your time management is always helpful. So some of the techniques included in that are remembering the tables and then remembering the squares of numbers up till at least 25. You can remember the cubes of at least up to 12. You can remember the square roots till 5. Even if you can do it till 10, that will be much better. Cube roots are not usually required. You can remember the factorials up to at least 7 or 8. So these are some general techniques that help you recollect the values much faster rather than calculate it in the rough space. Of course you can do it, but as I told you, why waste that time? You can use that time to think about a leaner and better solution process rather than wasting it on calculations. Alright, so 180 square would give you 32400. Alright, so that is already lesser than 331. So I should start attempting from 181, right? I should check 181 square and see if it is actually smaller. Okay, now what am I doing with the number and its next digit? Sorry, the number and its next number, right? Because if I check 181, I also have to check 182, so that 33127 falls between 181 whole square and 182 whole square, right? So it's just better to write down the squares along and then decide which numbers are you going to use. We are quite sure that it will be above or near about 180 whole square, right? So if I do 181 whole square, I'll get 32761. So 181 whole square, let us write it down for easier reference. So 181 square gives us 32761. Alright, so if n was 181, the first section is satisfied because 327671 is definitely less than 33127. Now I have to check n plus 1, right? So I'll check 182 square. Now 182 square is given by 33124. Alright, so this value is 33124. Now as I can see, this is very near to 33127, but 182 whole square is also less than 33127. So 181 will not get used, right? This is the first check that we have to conduct, because both n and n plus 1 would be less than our target number if we would have selected 181 as our n. So this is clearly evident now that if I try 183 square, that will be greater than 33127, right? So 183 square is actually 33489. All right, so we have n equal to 182. All right, this was just trial and error, and there are no better ways of doing it rather than calculating rough guesswork and then going by multiplication to calculate the squares near it. All right, you can use the a plus b whole square technique, right? If you know 180 whole square, you can, I'll show you one, right? So how do I calculate 182 whole square? Here is the technique. So 182 whole square will be 180 plus 2 whole square, right? Use the a plus b whole square technique, that would give you a square, so which is 32,400 plus 2ab, right? So this will be 360. Okay, 2ab, so this will be 720 plus 4, right? So this will give you 3 right? Because 400 plus 720 gives you 1120, so it will be 3320 plus 4. I'm sorry, one more 3, right? 33120 plus 4, that would give you 33124. Okay, you can add them down normally using a column formation also, but this is the way you have to proceed if you want a bit faster calculation. Otherwise you can just write them in a grid and multiply them as usual. Alright, that is also okay. Now the first part is done. Find the integer n that satisfies. Okay, so this is the first thing that we needed to calculate. Fine. Then find also a small integer m such that m plus n whole square. Now this we know as 1, right? So here we have to just calculate another integer n such that 182 plus m whole square minus 33127 is a perfect square. Right, now we have 183 whole square, so I can try with that. So 183 whole square minus 182 whole square, what would that give me? I am gonna use the a plus b into a minus b technique, right? So this is going to give me 1 into, what is the sum of these? So the sum of these would be, because if m was supposed to be 1, then their difference, that should be a perfect square, right? So this will be okay. No, I am not supposed to do this. I am supposed to do 183 square minus 33127. I am supposed to do this. So I'll need 183 square, which is 33489 minus 33127. This will give me 2 here, 6 here, 1 here, 162. 162 is not a perfect square, right? Because this is 81 into 2. Now if it is only 81, then something could have been done, but no, wouldn't work. Alright, let's try 184. Now 184 square, you can calculate it like this, right? Let us do it so that you have an exercise in how to do it. So 180 plus 4 whole square, that would give you 32400. This is the a square term, right? Then the 2ab term would give you 180 into 4 is 720, right? So 720 into 2 will be 1440. Alright, the b square term will be 16, right? So if we add these up, I'll get 6, 5, 8, 3, 3. So this basically becomes 33856 minus 33127, which is 9 here, 3, that gives me 2, and 8 minus 1 is 7. Jackpot, right? Because 729 we know is 27 square. This is because 729 is basically 3 to the power 6, right? From there we can understand. How do I know 3 to the power 6? Because I told you, you try to remember the powers of smaller numbers, right? For 2, remember up to 10. For 3, anyway, you remember until the thousandths number. Okay, so 2 to the power 10 is 1024, right? Remember till then. 3 to the power 6 here is 729. You can stop there. 4, if you take 4 to the power 4, that will give you 4 square into 4 square, 16 into 16, 256, right? So 4 to the power 5 will give you 512. 4 to the power, yeah, remember till that, okay? Because 4 to the power 5, 512 means 2 to the power 10 is 1024, alright? But 4 to the power 6 would give you 2048. So if you want, you can remember that, otherwise it's fine. For 5, remember up to 625, and then into 5 is 3125, alright? So these smaller calculations, if you remember, I know when I say this, it seems like I've memorized everything, but that is not the case. These are smaller numbers which you should have used often so as to remember the values. Alright, in many small calculations regarding numbers, you will use these values. So, getting back to our sum, 184 square minus 33127 gives us 27 square. So, what is 184? 184 is equal to 182 plus 2, right? Therefore, m equal to 2. Now, this is our second part calculated. Alright, m equal to 2. I should put this marking over here. Yeah. So m equal to 2 is done. Now what are they asking? Hence express 33127 in the form of p into q. Alright, so we have to express it in the form of p into q, which can be done easily from this statement. I'll mark it. We'll use this statement. So 184 square minus 33127 gives us 27 square, right? So if I move these, I'll get 33127 is equal to 184 square minus 27 square. Now this I can factorize as a square minus b square. So that will give me 184 plus 27 into 184 minus 27, right? So that will give me 111201, and this will give me 157, right? Is there any condition of generality? No. So p and q are integers greater than 1. This is obtained, right? Any one of them could be p. The other one would be q. Alright. So you do not need to make a particular choice on which one is p and which one is q. Any one of them could be p or q. Alright. 157 into, okay, did I make a mistake here? Sorry, it will be 2011. Alright. So 211 into 157. Okay. Now, what is the next part? The next part says, by considering the possible factorizations of 33127, show that there are exactly two positive values of m for which n plus m whole square is a perfect square, and find the other value. So 1 we have found out, right? N plus m whole square minus 33127, and find the other value. So if there are two exact factorizations possible, then one of them will always be 1 into 33127, right? Any number itself and 1 are always their factors. So the question wants us to show that there will just be two such factorizations. One of them will have to be by default themselves. The other one will be 211 into 157. Now this will happen only if 211 and 157 cannot be factorized further, right? Because if these can be factorized, then I can take out one factor from the left one and add it to the right one to make one more new set. But the question says that these are the only two sets possible. So we have to explain that 211 and 157 are prime numbers. Now how do you do that? We can do that via sieve of Eratosthenes, right? So sieve of Eratosthenes said that you can, it's basically not a theorem, it's an algorithm. So it says that you can take a prime number, divide it by 2, alright, and check if all the prime numbers from 1 to n by 2 divides that prime number. Okay, if your prime number is, okay, let's switch up the names of the values because n and m are being used here. Okay, let's say the prime number is p. Alright, then you check numbers till p by 2. Okay, this was the original method. So this says, I'll write it down. Take P, calculate P by 2, check if primes from 1 to P by 2 divide P. Now if any one of them does, if yes, composite, then it becomes composite. If no, prime. Alright, this was a very simple test devised by Eratosthenes in about 350 BC. So it's been in use since then. But nowadays we have refined this method and we only check to near about root P. Alright, so this is the faster method for computation. We can check up to root P. So checking up to root P, this is faster because you have to check less numbers, right? Because the difference between P by 2 and root P will increase as P increases. So for 211 we check primes up to, now we know 14 square is 196, right? So up to 15 we can check. For 157 we know 12 square is 144, so we check primes up to 13. I'm just adding one more extra because why not? You could check for less than root P, but you can check to the nearest integer to root P as well. Alright, so 211, let us not check with 1. 2, obviously it's not going to divide. 3, no, because some won't work. 5, no. 7, 3s are 21, no. 210 is divisible by 7, 211 is not. 11, no, because 11 ones are 11 and 101 is not divisible by 11. 13, 81, no, 81 is not divisible by 13. So prime, right? Prime. Now 157 won't be divisible by 2, obviously, because it's an odd number. 3, 5 plus 7, 12 plus 1, 13, no. 5, last digit is not 5. 7, 14, 17, no, won't be divisible. 11, no, because 11 ones are 11, 47, 11 fours are 44, 3 remainder, no. 13, you divide, you get 27, 1 remainder, so prime. Alright, now once we have established that these two are prime numbers, we are fairly sure that the other numbers that we obtain are the pairings of 1 into 3, 3, 1, 2, 7. Alright, now we have to find those numbers. Now, we know that this will be the pairing, but we have to find it in this format, right? N plus m whole square. So what are the two numbers whose whole square subtracted from 3, 3, 1, 2, 7 is a perfect square? We have to find it in that format. Alright, so to find it in that format, we will just assume k square. Okay, so we will assume we have the value of n, right? We know n equal to 182. So I will give you 182 plus m whole square minus 3, 3, 1, 2, 7 equal to k square. Alright, now we will find k. Now remember, one of these will lead to this pair, the other will lead to this pair. We do not need to find out which k will lead to the original pair, right? So I'll bring the text a bit down. So there are the two pairs just below the camera that I've written, 1 into 3, 3, 1, 2, 7 and 211 into 157. 211 into 157 is the pair that we already know. We need to find k such that we meet the conditions of the first one. Alright, so how will we go through it? Let's calculate. So here I will just factorize it, and upon factorizing I'll get 3, 3, 1, 2, 7. Same logic, right? A minus b whole square, this logic. So here I'll get 182 plus m minus k, then 182 plus m plus k, right? This is the factorization we'll get. Now once we know that there are only two possible pairs, we will not obviously work with the pair that we already know, right? So we know that this is equal to 1 into 33127. So the larger value will be taken as positive, right? Because this is all plus, right? So this all plus should be equal to the positive value, and here the smaller one should be equal to 1. Therefore 182 plus m plus k is equal to 33127, which means m plus k is equal to, subtract it, you will get 5 4 9 2 3. Alright, and then you have 182 plus m minus k is equal to 1, which will give you m minus k equal to minus 181. Alright, now if you add these, you will get 2m equal to 3 2 4 6 7, which would give me m equal to 32 sorry, so I'll get 16 here, then I'll get 38 and then 2. Alright, so we should get the value of k. M minus k is equal to 181, right? So k should be equal to 16382 minus k is equal to minus 181. Sorry, so this means k will be equal to, we have to add them, 3 16 5 1 6. So therefore 33127 should be equal to, okay, so n and m, this is what we had to calculate, right? So 182 plus 16, okay, wait, so we get m equal to 16382 and k equal to 16563. So this is what we get, 16382 whole square minus 33127 would be equal to 16563. This is one equation of this particular format, and the second equation of this format is obtained by using these two numbers, right? 211 and 157, right? So again we can use this 182 plus 157 whole square minus 33127 is equal to 211 whole square. So these are the only two possible results, two possible solutions. One of them was given and the other we had to calculate. Okay, show that there are exactly two positive values of m. We calculated the other two. Okay, now the solution here is nothing that you would have not studied earlier, right? These are things that have been taught to you very early in your school life, but we have not used them in such a way. Alright, I took my time to detail and explain to you all the steps because these are technically easy sums, but easy sums give you a much more headache because you have a lot more options to work on and therefore you can get lost in many ways. Okay, now if you do have any questions relating to this exam or relating to this video, you can drop a WhatsApp at this number. Okay, our team will get back to you. Alright, if you want, you can always put your queries and suggestions and feedback in the comment section of the YouTube video, but if you do not wish to type there, then you can of course use this number as a contact point. Alright, I have had this number on the screen for a long time, so I hope you have all noted it down, and do let us know if you have any problems or you need any classes for this course. Okay, that's it. I'll see you in the next one where we will discuss some other question from the past years. Alright.